Hello everyone. So let's now solve practice assignment week 11, question number 3. Let f of x comma b defined like this is defined on the box where x value lies between -2 and 3 and y value lie between -1 and 4. Then which of the following options are true? Option are asking us to check the maximum and minimum value of the function, at what point they occur and what is the value. So given our function, let's simplify the function first. Now if we want to calculate the maximum and minimum value of the function, like at what point they occur. So for that, we need the critical point of the function, and for that, we need to calculate the gradient of the function, set it to 0. So the gradient of the function would be 18x plus 72 xy, comma 36 x square minus 4. If we set the gradient to be 0, 0, we will get two equations: 18x plus 72 xy equal to 0. So this is equation 1. 36 x square minus 4 equal to 0. This is equation 2. So from equation 2, 36 x square minus 4 is equal to 0. So x square is 4 by 36. So x is plus minus 2 by 6. That is x is plus minus 1 by 3. So this is the one result that we get. Now let's do it here. From equation 1, that is 18x plus 72 xy equal to 0. If we divide both sides by 18, we get x plus 4x y equal to 0. We can take the x common and we will get 1 plus 4y equal to 0. So either x would be 0 or 1 plus 4y equal to 0, and that would give us y equal to 1 by minus 1 by 4. Now one thing, that for the critical point, both these equations should satisfy simultaneously. So if x would be 0 here, then the second equation would not be satisfied because the root of the second equation is plus minus 1 by 3. So that means here x value cannot be 0. So we will exclude, sorry, we will exclude this case. So the critical points that we will get, will be 1 by 3 minus 1 by 4 and minus 1 by 3 minus 1 by 4. And notice that both of them lies inside the box made by this. So let's first uh, check how this box will actually look on a 2D plane. So if this is our R2 plane, like the function would be in R3, but let's assume now for it in R2. Now our x value is between -2 and 3. So let's suppose -2 is here and 3 is here, and y value is between -1 and 4. So -1 and 4. So something like this would be the, it would be kind of rectangle, and our function would lie inside this rectangle. Now both our critical point 1 by 3 comma minus 1 by 4. So 1 by 3 comma minus 1 by 4 would lie some here, and minus 1 by 3 minus 1 by 4 would lie something here. So it lie inside the given bound on the function. But that would not be enough to check the maximum minimum value of the function. In a scenario like this, where function is bounded within some shape like rectangle or square or circle, we also need to consider the edge cases. That is, what will be the function value along these edges and the vertices also. So let's first note down the vertices. So the vertex points are -2, -1, -2, 4, 3, 4, and 3, -1. So these are the vertex points. Now we will look at the edges. So let's first look at this edge. That so the equation of this line would be here, and the y is changing and x is constant. So the equation of the line would be x equal to -2. So along the line x equal to -2, our function is 9x square plus 36x square y -1 -4y, and here it would be, we will put x equal to -2. So it would be 36 plus 144y -1 -4y, so 140y plus 35. Now if we take the derivative of this function, now it would be just a function of y. On taking the derivative of this function with respect to y, we will get 140. So it is a constant. So the critical point will not exist at this point. So we will not consider any point along this line. Now, similarly, if we check for along the line, that is x equal to 3, our function would become f of 3 comma y. So plus 324y -1 -4y, so 320y plus 80. So again the derivative would be some constant term, that is 320. So no critical point will exist. So along these lines there are no critical points. Now let's look at along this line. So the equation of this line would be y equal to 4. So our function was 9x square plus 36x square y -1 -4y. Now it will become f of x comma 4. And 33x square minus 17. Now if we take the derivative of this function with respect to x, we will get, and we can see here, if we put this derivative equal to 0, we will get the critical point is here we will get x value to be 0 when we put the derivative to be equal to 0. So the point would be 0 comma 4, as we will take the y value here. Now same thing we will do along the line y equal to -1. So 9x square minus 36x square minus 1 plus 4. So minus 27x square plus 3. So again the derivative of x would be so if you set this to 0, we will get x value to be 0. So the critical point would be 0 comma minus 1. So the total points that we have to consider is these two critical points that we got from the function, these four vertices, and these 2 points that we got here. So total points are 8. One by 3 comma minus 1 by 4 minus 1 by 3 minus 1 by 4 minus 2 comma minus 1 minus 2 comma 4 3 comma 4 3 comma minus 1 0 comma 4 and 0 comma minus 1. So we will check the function value along these 8 points and conclude where it is maximum or where it is minimum and at what point it is maximum or minimum. So let's note down the function once again. So let's check it at 1 by 3 comma minus 1 by 4. So it would be now this would cancel out to 1 and here also this would become 1 by 9 into 1 by 4, so it would become 1 by 36. So this would also become 1 but negative and this negative 1 and here it would become positive 1, so we will get 0. So the function value at this point is 0. Now for next point, now it won't be any effect because here it was 1 by 3, it was negative 1 by 3 here, but as you are squaring, so the sign will not have any effect. So again the function value at this point would also be 0. Now let's check against the vertex point. So minus 2 comma minus 1. So it would be 9 volt. Okay, negative 144 plus 4 minus 105. So this is the value that we will get at minus 2 comma minus 1. Now let's check it at minus 2 comma 4. So it would be 595. 1360. Now at the point 3 comma minus 1. So negative 240. Now the remaining 2 points, that is 0, comma 4 and 0, comma minus 1. So this would be minus 1, minus 16, that is minus 17. F 0, comma minus 1, minus 1, minus 4, minus 1. So it would be 3. So now if we check the maximum value of the function, it occurred at 3, comma 4, and that is the value 1360. And if you look for the minimum value of the function, okay, here it is 0, here negative 105. Okay, so negative 240 that occurred at 3, comma minus 1. So the minimum value occurred at 3, comma minus 1, and maximum occurred at 3, comma 4, and these are the maximum and minimum value of the function. Now let's look at the option. 3, comma 4 is the point of absolute maximum. Yes, this is the maximum value of the function that we got. So this is the correct answer. So let's now see a different approach for the same question. So our function was given to us was 9x square minus 1 into 1 plus 4y. So this was our function, and our function is bounded between these regions where x value is between negative 2 and 3 and y value is between negative 1 and 4. If we look at the function, there are function, so this part is only for the x and this part is only for the y, and it is the product of these two terms. So now let's call this as, so this is our term 1 and this is our second term. So, and this is only for the function of x and this is only the function of y. If you want the maximum value of this function, it is the product of these two terms, and when these two terms will get their maximum value, their product will also be the maximum value. So that means this whole function will get maximum value when these individual terms will get maximum value. So if we focus on, let's say, the first term, it is 9x square minus 1. Now here, because x is, we are squaring, so it will always be positive. So it doesn't matter if we take the negative value or positive value, it will always be the positive value. So within this range, we want the highest value in terms of the numerical value, not the sign, because the sign will not matter as we are squaring it. So within this range, the x value will be maximum at 3. So the function will, this term of the function will attain its maximum value when x value would be 3. So here x value would be 3. Now for the y part, if we want to maximize this, it is a linear function. So it will be maximum when we will take the y value to be the maximum. So the y value would be maximum at 4. So the 4 is the maximum value of the y. So here we will get y to be 4. So this term will achieve maximum value when x would be 3, while this term will achieve its maximum value when y would be 4, and the product will get maximized, that is the whole function will get maximized when your individual term will get maximum value. So we will get maximum value of the function x comma y at 3 comma 4, and if we put f of 3 comma 4, we will get its value, that would be 9 times 3 square minus 1, 1 plus 4 into 4, that is 81 minus 1, 1 plus 16, 80 into 17. Okay, so just how we check for the maximum value, let's try finding out the minimum value of the function in the same manner. Now, if we notice this term, if we want, uh, our goal is to find the minimum value now. Now, this term in this range of the x can never be negative and can never be 0 also. But we know that as this function 1 plus 4y is a linear function and within this range, it can be negative. So, if and it is a product of these two quantity, and if we are going to take the maximum value of the function, while if we somehow get the minimum value of the function and we know that can be negative, so the total product would come out to be negative as it would be from positive quantity always and it would be a negative. For the total product of these two terms, we will get a negative value, and because it is the highest value of this function, if we will take the highest value of this function and the lowest of this function, the product would be the lowest of the function value. So the highest of the function again occurs at the 3, while the lowest of this term 1 plus 4y occurs at negative 1. So the minimum value of function occurs at 3 comma negative 1.